The topic for Lesson 12.1 is three-dimensional figures. You'll learn to use orthogonal drawings of three-dimensional figures to make models and identify and use three-dimensional figures. Why are three-dimensional structures valuable to archaeologists? Archaeologists and Egyptologists continue to study the Great Pyramids of Egypt. Drawings of these three-dimensional structures are helpful in their study. If you see a three-dimensional object from only one viewpoint, you may not know its true shape. Here are four views of the Pyramid of Menkaure in Giza, Egypt. The two-dimensional views of the top, left, front, and right sides of an object are called an orthogonal drawing. The view of a figure from a corner is called the corner view or perspective view. You can use isometric dot paper to draw the corner view of a solid figure. One corner view of a cube is shown at the right. This is kind of a goofy example. They ask us to draw the back view of a figure given its orthogonal drawing. I say it's goofy because if you know what the front looks like, the back is going to be remarkably similar. The difference is it's just reversed. So it's the same outline, just reflected. Now if they ask for the corner view, that gets a little more interesting. The easiest way to do it would be to use blocks to make a model so you can see what they're making. Then you could turn your model so you're looking at the corners of the blocks. The lowest column should be in the front so the differences in height between the columns are visible. And then you could connect the dots on isometric dot paper to represent the edges of the solid, shade the tops of each column. To do this well, it would take time. On the other hand, if we just want to identify three-dimensional figures, that can go very quickly. A solid with all flat faces that enclose a single region of space is called a polyhedron. Each flat surface or face is a polygon. The line segments where the faces intersect are called edges. The edges intersect at a point called a vertex. A prism is a polyhedron with two parallel congruent faces called bases. The other faces are parallelograms. The intersection of three edges is a vertex. Prisms are named by the shape of their bases. A regular prism is a prism with bases that are regular polygons. A cube is an example of a regular prism. Some common prisms are shown below. So a triangular prism has, here's a vertex, this is an edge, that rectangle makes a face, and the bases would be these triangles. It's whatever shape we could slide all the way through and be consistent throughout. Now, in a rectangular prism, we could pick any one of the faces to be the base, because I could always slide the rectangle through. In the pentagonal prism, the way they have it drawn, the pentagon is in the front, would have to be the base because that's the shape that could slide all the way through the figure. So the height, when we get to volume very soon, will be the side that is perpendicular to that base. A polyhedron with all faces except for one intersecting at one vertex is a pyramid. Pyramids are named for their bases, which can be any polygon. A polyhedron is a regular polyhedron if all of its faces are regular congruent polygons and all of its edges are congruent. There are exactly 5 types of regular polyhedra. These are called Platonic solids because Plato described them extensively in his writings. Plato was a teacher of mathematics and philosophy around 387 BC. He founded a school in Athens, Greece called the Academy. There are solids that are not polyhedrons. All of the faces in each solid are not polygons. A cylinder is a solid with congruent circular bases in a pair of parallel planes. A cone has a circular base and a vertex. A sphere is a set of points in space that are a given distance from a given point. Identify the solid, name the bases, faces, edges, and vertices. This solid is a rectangular prism. The bases are rectangle A, D, E, H, BCH, and rectangle BCFG. The faces are made up of these 6 rectangles listed: AGBH, rectangle CDEF, rectangle ABCD, rectangle EFGH, and rectangle ADEH, and rectangle BCFG. The edges are sides, segments AB, CD, EF, GH, AD, BC, FG, EH, BG, AH, CF, and DE. And the vertices are A, B, C, D, E, F, G, H. Okay, that would be a lot of writing, even though it's not very difficult. Let's look at a shorter one. Identify the solid, name the bases, faces, edges, and vertices. Much shorter. This is a cylinder. Check. The bases are circle M and circle N. Check. There are no polygons, so there are no faces, there are no edges, and there are no vertices. Again, identify, name the bases, faces, edges, and vertices. The base is a triangle, and the remaining 3 faces meet at a point. So that means this is a triangular pyramid. The base, they called the base the bottom. You could have picked it as any of them. They said the base was triangle ABD because it's on the bottom, but they could have said ACD. It doesn't matter. The faces, now they list all 4 triangles that are faces. The edges, and there are 1, 2, 3, 4, 5, 6 different edges listed. And the vertices are the 4 vertices. Okay, so this is a nice illustration. Prisms can be oriented, so nope. Interesting shapes can occur when a plane intersects or slices a solid figure. If the plane is parallel to the base or bases of the solid, then the intersection of the plane and solid is called a cross-section of the solid. Okay, the shapes this would make, this one, if it's parallel to the base, that would make a circle. At a slant, that would cut an oval, which in high school we call an ellipse. And if it was cut perpendicular to the bases, that slice would be a rectangle. This lovely blue diagram represents a 2-layer sheet cake. Describe the possible cross-sections of the cake. If the cake's cut horizontally to taste the creamy filling, it would make a rectangle. If you cut the cake vertically to start to slice it, the cross-section would also be a rectangle. Cross-sections can be things other than rectangles. We saw that already. A solid can be determined from its orthogonal drawing. Solids can be classified by bases, faces, edges, and vertices.